Pointers. 12.1 Pointers Introduction. Pointers are the most important concept in C language. By using pointers, we can increase the efficiency of the C program. In other words, more specifically, we can reduce the role of compiler. You know, compiler is the translator. Translator's role is reduced, automatically efficiency is increased. Just for example, you do not know my language, I do not know your language. You want to learn C language from me. All of you came here. Then what should we do? We have to engage a translator who knows both the languages. Whatever I teach, it translates into your language and explain. Whatever you ask, it translates in my language and explain it to me. So in that way, we can share our knowledge. So now what happens? Suppose this chapter I may take 2 hours time normally. Then because of this translation, I am taking 4 hours. 4 hours. So if you are able to reduce the role of translator, what happens? It may be completed within 2.5 hours or 3 hours. By that, indirectly, we are increasing the efficiency. That is, we are reducing the overheads. So by using point, now we are learning using high-level language. But these pointers are one of the low-level notation of C language. One of the low-level notations of the C language. Already, one of the elements I introduced in the form of bitwise operators. Bitwise operators, in the operators chapter I explained, those bitwise operators act at low level, at bit level. In the same manner, pointers also low level, at low level they perform operations. That's why some people call C language as middle level language. Low level languages are there, high level languages are there. C, generally it is treated as high level languages, as it consists of both some low level features like bitwise operators, pointers and all that. It is called middle level language. By using pointers and other bitwise notations and all that. Now system programming also, this is whatever we are doing is application programming. System wise program also can be performed. That's why this is called middle level language. Now if we come to pointers, by using pointer notations, we are almost developing low-level notations. Those are not exactly low-level notations, but by using pointer notations, we can reduce the role of compiler. By that, overheads are reduced and program efficiency is increased. Actually, here one secret we did, I have to explain to you. That is, according to our habit, for everything we give name and call. All programming elements we give names and use it. So it is convenient for us. Calling your classmate with names is very convenient to you instead of using their roll numbers. Understand? Here if you come to system, actually we accustomed to names and processor knows only addresses. Particular address, whatever value is there you take, like that only. It does not know all these names. So compiler, suppose if you write age and 5 is stored, compiler will tell in a particular address a value is stored, you take that value and process. Understand? So that is a overhead for us. Compiler takes up this responsibility, it is a overhead for us. By using pointer notations, we are able to almost closer to address, we can communicate to the processor and the processor can understand it easily like a low level language and compiler's role is reduced. That is the technique. So here now you see the same old example I am giving, int v 10. Then what happens? This is a variable, its type is int and its value is 10. Obviously, it is having some address. address. So far, I am talking about this address, but if you want, you can retrieve it also. That the corresponding code, you know that is and v, address of v. Now you see this program, 12.1, page number 630. Age is 10, and age you have written ninth line. You are getting the value. Ampersand age and age you have written. You retrieve the address. Just to see the figure beside it, alongside. Now, here one more point you remember. 10th line, 9th line we have used percentage d. For retrieving value, signed integer we have used. For retrieving address, unsigned int, percentage u. So, whenever, just remember that, whenever you have to retrieve address, use percentage u. So, what you can understand, you are able to retrieve the address of variable. So, you are able to retrieve the address. So, the same thing, if you are able to communicate to the processor can easily understand. Processor deal with addresses and the value stored in particular address. So, then compiler's role is reduced and we can almost directly communicate to the processor. That's why the efficiency of the program is improved. So, once you are able to store address of a variable, there should be a special type of variable to store that address. Such type of special variables are called pointer variables. Just to understand that an ordinary variable can store a value of a particular type. Now, int v, this can store an integer value. Float f, it can store a floating point value. Char c, it can store a character value. So, these types and ordinary, these are, let us call them as ordinary variables. Ordinary variables can store a value of that particular corresponding type. Now, pointer variable is different. Pointer variable is meant for storing an address. Using pointer variable, we can provide address to the processor, and then compiler's role is minimized. What compiler is doing on our behalf, that we are doing using pointer variables. So, you must understand this point. Actually, now how can you differentiate ordinary variable and pointer variable? Ordinary variable can store an ordinary value, a value of a corresponding type, and pointer variable can store an address of any variable. It cannot store ordinary values. It can store the address of not only variables. We deal with the different types of elements, variables, constants, arrays, strings, structures, unions, files, functions, and for all the elements, addresses are there. So, pointer variable can store all the addresses of particular elements, programming elements. So, by using pointer notations, we are able to communicate to the processor directly. Not exactly 100%, but only thing is we can minimize the role of compiler. By that, overheads are reduced and program efficiency is increased. And one more thing I have to tell you, this address is not constant. From the beginning I am telling you, the address is a system dependent factor. Now this time if you compile, you got this. Next time same program you compile, you may get some other address. On different compiler you work, you may get some other address. This is not constant. It is totally system dependent. For every run, you may get different addresses. So, don't use absolute address of any programming element. Use, now this is the notation. Suppose for this address, and v, and age, and roll number, that only you have to use. In no case, you use absolute addresses of the programming elements. So, program pointer variables are meant for storing addresses of programming elements, and in this chapter, in the remaining concepts, how to declare pointer variables and other allied issues,